Yes, Assalamu alaikum everybody. Dear students, I welcome you again to this sixth. This is the sixth lecture. It is lecture number 6. This will be now the Clairaut's differential equation and its solution. And before you go through this lecture number 6, you should go the lectures from 1 to 5. These are the lectures. So equation is solvable for P, and we have also done the differential equations in different forms when we solve for P. Now, finally, we are coming to this Clairaut's differential equation. Actually, this Clairaut is the mathematician. It was a French mathematician. Named Alexis Clairaut. The great mathematician, French mathematician. He was astronomer and geophysicist. He lived from 13 May 1713 to 17 May 1765. The great mathematician. He is also known as the Clairaut is also known as the prominent Newtonian. There are so many results of Newton that Clairaut proved by two different forms. Two important equations are there. One is Clairaut's relations, Clairaut's theorem, Clairaut's this differential equation. Actually, Newton had this outlined some fundamental laws related to astronomy. Newton had outlined in Persia, he outlined some laws in 1687. He outlined some laws, and the work of the Clairaut's worked very hard, and his work proved the validity of the results of Newton. That is why Clairaut is sometimes known as prominent Newtonian. He visited Lapland, and his visit was there to prove the result which Newton had outlined for the this figure of the earth, and he established a theorem known as Clairaut's theorem on the orbit of the earth. Very important theorem. Then he proved this Clairaut's relations, and we are now discussing the famous result of this great French mathematician Clairaut's differential equation. It has a tremendous application in physics and other parts of science. You see, it is very simple. Some of you will certainly ask that we have already done this, because this is the case where we write variable separable method. When we have y is equal to some function of x and p. You have done the case in this equation is solvable for P. The first case we discussed with you was when y can be expressed as a function of x and p. Similar is the case in this Clairaut's differential equation. Now, what is this Clairaut's differential equation? It is a differential equation of the form. A differential equation of the form. It is y is equal to x times dy by dx plus f of dy by dx, some function of dy by dx. This is the actually Clairaut's form, where f of dy by dx is some function of dy by dx and is continuously differentiable. It is continuously differential. It is actually the differential equation. This is the Clairaut's differential equation. A differential equation of the form this y is equal to x dy by dx f of dy by dx, where f of dy is some function of dy by dx and is continuously differentiable, is called Clairaut's differential equation. Now you may ask why we name this equation, because we have already done, you will just see we have solved such differential equations previously when we discussed case first, where we said that we write y is a function of x and y exists linearly, y can be expressed on one side explicitly, then we differentiate with y with respect to x and solve. Case number first, you should switch to that, perhaps it is in lecture 4 or lecture 3, where we write y as a function of x and p. Here it is also. But the utility of this result is Clairaut's form very interesting. When we replace this by p, it becomes y is equal to px plus f of p, some function of p. The solution will be of this differential equation. If you want to find out the solution of this, you will see we simply replace p by c, constant, arbitrary constant. That is the solution. You will see just. Let us now go to the solution of this differential equation, which was established. This differential equation was established by Clairaut. Let us go to this solution. I will discuss the solution of differential equation. Well, this is the solution of Clairaut's differential equation. Consider Clairaut's differential equation. What is this? Y is equal to x times dy by dx plus some function of dy by dx. Let me put here as usual what we did previously. I put p is equal to dy by dx. When we put p is equal to dy by dx, what you get? You get y is equal to px plus f of p. This is now Clairaut's differential equation. Note that y is here dependent variable, x is independent. P is dy by dx here. So you go to case number 1 that we discussed in previous lectures. You have the previous lectures with you where we have said that there are different cases. One case is when y is a function of x and p. Second case is when x is a function of y and p, and so on and so forth. This same case is here. We have to simply differentiate this. Differentiate with respect to x. This will be your dy by dx is equal to, it is 1p plus x dp by dx. Here p is a function of x and y both. You will write this, it is f dash p into dp by dx. This is your p is equal to p plus x dp by dx plus f dash p dp by dx. Well, this implies 0 is equal to x plus f dash p, take dp by dx out. This one simplification will give you you see what you get. This gives you x plus f dash p dt by dx is equal to 0. You can write here when dt by dx is 0 and x plus f dash p is 0. We take this, even we can get p from this also. I will tell you what, if we eliminate p between this equation and the given equation, what we get. That will be the singular solution. We may require it in certain cases, but here the interesting thing is, you take this, solve this, it is dp is equal to 0, integrating on both sides. This is p is equal to 0 plus c, that is p is equal to c. Using this c, using an equation, first, what was that? It was y is equal, I will write again it, y is equal to px plus f of p. This was the Clairaut equation. You have got the solution, y is equal to cp plus f of c. So it is y is equal to, sorry, c, p is replaced by cx, y is equal to cx, replace p by c, it is the equation. This is cx plus f of c. What an interesting thing it is. Whenever you come across a Clairaut equation, you have not to go, it is solution in deep. Once you see the equation is of this form, y is equal to px plus f of p, where p is dy by dx, you have to write down simply solution. Replace p by some arbitrary constant, y is equal to cx plus f of c. This is the solution. You see, if you find p here also, you can also get p here. Use the p in given equation. That will give you singular solution. I will write here for your information. I will write here. Otherwise, we have solved the Clairaut equation. We have given you the method for solving the Clairaut equation, and you will also remember this in what is the solution. If we eliminate p between given equation and equation number 2, that is this, you can also get p from here. You could get p from this relation, that is p is equal to c. Use a p in the given equation, that is also the one solution. That is called the Clairaut solution. But when you eliminate p between the given equation and this equation, we get the solution called singular solution. Note it. That will be called singular solution. It is a particular solution known as singular solution if you form the p from this factor which does not involve derivative. Here you found out the p from that factor which involves the derivative. Here p from that factor which does not involve the derivative. The solution will be called the singular solution. That is it. This is what we mean by this Clairaut differential equation and it is solution. Let us now go ahead. I will discuss with you some applications. I will discuss some applications. Suppose I take application from this book. It is say it is y is equal to px plus a by p. Suppose you want to solve y is equal to px plus a by p. It is obviously Clairaut equation where p is your dy by dx. It is a Clairaut equation. So you can write solution directly. What will be the solution? Solution will be y is equal to cx plus a by c. P is replaced by c. If you go by long method, you will differentiate this. It is dy by dx is equal to p plus x dp by dx. It is plus derivative of p minus a by p square into dp by dx. Because derivative of 1 by p with respect to p will be 1 by minus 1 by p square, and that p with respect to x is dp by dx. This is P is equal to P plus X minus A by P square dP by dx. This goes, this is X minus A by P square into dP by dx is equal to 0, which gives us dP by dx is 0. That gives dP is 0 by integrating on both sides. Integral of dP is equal to 0 plus C, that is P is equal to C. Use in first equation, that will be the solution. It is y is equal to Cx plus A by C. Now if you find P from this factor, find P from this, X minus A by P square is equal to, it is X is equal to A by P square, that gives P square is equal to A by X, or P is root of A by X. Use in first, what you get the singular solution. So you can find out the singular solution, as well as sometimes you are asked to find the singular solution of the Clairaut's differential equation. In that way you have to eliminate the P from that factor which does not involve the derivative, and when you find out the direct Clairaut solution, you have to find out the P from that factor which involves P. Let me have some more problems on this. Let us have one more question. Suppose you want to solve y is equal to px plus p minus p square. Solve y is equal to px plus p minus p square. Solve y is equal to px plus p minus p square. If you observe this differential equation, it is clearly Clairaut's equation. Y, x here linear, P, this should be necessarily here, y is equal to px. Here you have some function of P. This function of P this part should not involve x. This part should not involve y. If it involves constant and P, still it is a function of P. But it should not involve x and y. So we say it is a Clairaut's differential equation. If you want to solve it, also write it is singular solution. You want to solve it and also write it is singular solution. How will you go? You will differentiate this. Differentiate with respect to x. This will be dy by dx is equal to, it is x plus it is p plus x dp by dx plus derivative of p with respect to x is dp by x minus derivative of p square, it is 2p, then p is dp by dx. This gives you p is equal to p plus, it is x minus 2p. This is x minus 2p plus 1 is also here. What is this one? It is dp by dx. dp by dx and this dp by dx. Okay, it is okay. This implies that either you have dp by dx 0 or you have x minus 2p plus 1 equal to 0. And when you solve this, this is dp is equal to 0. This implies p is c. How? By integrating it on both sides. Use in first. Use this in first, you get the solution. Y is equal to, you see how the solution is getting. Simply replace p here by c. It is cx plus c minus c square. This is the solution. Now you want to find out the singular solution. You have from this, it is 2p is equal to x plus 1. This gives p is equal to x plus 1 by 2. Let us use it also. Use this also in first. Let us use this p is equal to in first. What you get? When you use p, is x plus 1 by 2. This will be y minus x plus 1 by 2 into x plus 1 minus x plus 1 by 2 into x plus 1 by 2 square. This is y. It is y is equal to, sorry, y is equal to px plus p minus x plus 1 by 2. It is due at this p. I am using this one. Okay, this will be y equal to, take here 2, it is x square plus x plus 1 minus x plus 1 square by 4. This gives y is equal to x square plus 2x plus 1 minus x plus 1 square by 2 by 4. This gives you, this is y is equal to 4 LCM. This is 2 times x plus 1 square minus x plus 1 square. This is y is equal to x plus 1 square by 4. This is your singular solution. This is singular solution. So you have come to know how we write down the solution of the Clairaut distribution and how we write it as singular solution. Singular. Let me take one more problem. Suppose you have a question here, p is equal to log of px minus 1. Solve. Solve the differential equation. P is equal to, it is p is equal to log of px minus 1. Now let us see, I can write this as, this p I can write log of e raised power p is equal to log of px minus 1. So this is e raised power p is equal to px minus y. This simply means it is y is equal to px minus e raised power y. What is this number? It is e raised power p. What is now? Y is equal to px minus some function of p. It is a Clairaut equation. Clairaut equation. If you want to write down the solution directly, in case of MCQs, some objectives, you are asked the question in 2 marks question, 1 mark question. So in that case, you have not to go for this solution but extra. You have to, whenever you come across a Clairaut equation, what you have to do? You have to replace p by simply 3. You will write here, it is solution is what? Y is equal to cx minus e raised power c. But if we want also it is singular solution, also find singular solution. If you require singular solution also, so in that case we will differentiate it, no problem. We will write it as dy by dx is equal to p plus x dp by dx, then minus e raised power p into dp by dx. It is p is equal to p plus x minus e raised power p dp by dx. This goes x minus e raised power p is dp by dx is equal to 0. So how will you proceed? How will you proceed? One factor is your dp by dx is equal to 0. Another is x minus e raised to power p is equal to 0. Now from here, this will give you dp is equal to 0, that is p is equal to c. Use in first, this is the complete solution you will get. You will get the solution when you use it in first. You will get the solution. Solution will be c is equal to log of cx minus y, or you will write solution is y is equal to cx minus e raised power c. This is also the solution. Now if you write c here, p, you will find x is e raised power p. That is p is equal to log x. If we take log on both sides, we get p. Use p is equal to in this. Using p in this, it is log of x. Use p in first equation. It is p log of x is equal to log of log x log x minus y. This gives x is equal to x log x minus y. This gives y is equal to x common log x minus 1. This will be the solution, the singular solution. If you eliminate p from the other factor, this will give you the singular solution. This is how we solve such problems, finding the singular solution. And this. Let us have, we have to finally discuss now with this what is known as this equation is reducible to Clairaut's form. I will give you later on some methods how we reduce. Let us have one more question. It is y minus px square. Suppose it is solved. You want to solve y minus px square by 1 plus p square is equal to e square. What is it a solution? You can write this is y minus px square is a square into 1 plus p square. This gives y minus px is a under root of 1 plus p square. This gives y is equal to what? Px plus a under root of 1 plus p square. What is this? It is Clairaut's form. It is a Clairaut's differential equation. So what will be the solution? Solution will be y is equal to p is c x plus a under root of 1 plus c square. You can write as it is y minus cx square is a square into 1 plus c square. It is same equation. You see, y minus cx square by 1 plus c square is equal to a square. That is, we could replace here p by x, and we could transform this into Clairaut's. The solution is same. In the same equation, we have replaced this p by c. This is the solution. This is Clairaut's form. Let me have one more question. You have a question here. Suppose it is y minus px, p minus 1 is p. Solve y minus px, p minus 1 is p. This is the differential equation. Solve. You see, if you write this equation, it is very simple. Y minus px is p by p minus 1. That is, y is equal to px plus p by p minus 1. Nothing. This is your px. This is your function of p. You can write the solution by Clairaut. You see, this is the utility of this Clairaut's differential equation. The main thing is, whenever we come across a Clairaut's differential equation like this, we can write down the solution directly by replacing p some constant. It is y is equal to cx plus c by c minus 1. This is shortcut method. If you differentiate this on both sides, there you will get dy by dx equal to dp by dx is equal to 0. That gives p is equal to c. Use it here. It is also a solution. This is how we solve the differential equation, this Clairaut's differential equation. This was a Clairaut's differential equation. You see how we go ahead. Sometimes we come across, suppose if we have, it is a application of this, Clairaut's form where we apply it. Suppose I have p is equal to dv by du. P is dv by du. I want to form a Clairaut's differential equation according to this. What would be the Clairaut's equation corresponding to this p? What is Clairaut's equation corresponding to this p? So we can write Clairaut's equation will be according to this: V is equal to Pu plus some function of P. What is this P? It is U, independent variable. This is dependent variable. U, just as you write there, Px. It is here Pu plus f of P. So what is solution? What will be solution? Solution will be V is equal to Cu plus f of C. This is the solution. Suppose in certain cases you have a differential equation like this. You write dr by d theta is equal to p dash. Somewhere you have dr by d theta is equal to p dash. Corresponding with this, what is the Clairaut's differential equation? Clairaut's equation will be here: r is equal to p dash theta plus some function of p dash. So if dr by d theta is p dash, my Clairaut's equation should be of this form. So what is the solution? My solution will be r is equal to c theta plus f of c. This is how we write. I have just given you this idea, this method, because we want to now take the it may be the last lecture on this. It is equations reducible to Clairaut's form. We can reduce some equations. Somewhere it is possible to reduce the differential equations by a change of variable method. By change of variable method, you can reduce the differential equation to Clairaut's form. When it gets reduced to Clairaut's form, then you have not to go for its solution. Whenever it takes the form, Clairaut's form, you have to simply replace there P by C. If it is P dash, then take it by C. Then that will be the solution. With this, I close this lecture. It was this lecture number 6 on this Clairaut's differential equation. Very simple, because it seems very simple, because you have previous this lectures you have touched lecture number 4, 5, then 3 on this equation solvable for P. Actually, you have done there what is Clairaut's equation is, but here we have specified this Clairaut's differential equation. And the main thing is, if we come across a Clairaut's differential equation, how we write it its solution. How we write it is directly in one step we can write down it is solution. That is it. So next I will discuss with you some equations. How can we reduce by change of variable some equations into Clairaut's form, and what will be their solution? Thank you very much. I hope we will see next. Thank you.